So, all right. Well, thank you, everyone. We'll keep the banter to a minimum so we can talk about more interesting things like monorepos and NX and fast builds. And just a quick intro, Victor and myself are co-founders of Narwhal. We're the company behind NX. We have a lot of background in Angular. We both were on the Angular team at Google. Now we've been at Narwhal for just over 3 years. We've got a team of great Angular experts as well as React experts, people who just love build tooling and love monorepos and love infrastructure and those kinds of things. And now we help clients solve these big challenges that we're solving with NX and with frameworks like Angular, and having a lot of fun doing it. So we'll talk today. We're going to talk through NX, and we'll talk kind of end-to-end NX, but we'll take kind of a shallow look at what NX is and the monorepo setup and kind of how it works, and then look a little bit more deeply at the smarts NX has about building applications, which is some of the place where we've had a lot more innovation lately, and something that solves some real pain points for a lot of teams. So there are 4 parts. We're going to talk about monorepos in general, like what is a monorepo, and to us, what does it mean? And then what are the downsides, like typical downsides of code co-location, which isn't the same as what we talk about when we talk about monorepos. But we'll talk about what some of the typical challenges of that. And then we'll talk about what NX is and how it addresses those challenges. And finally, how NX makes builds fast. What's the magic? So let's start with monorepos. By the way, if you see that pig icon in the corner, that just means it doesn't mean anything special other than a note to me that I need to progress this slide manually. And because pigs are great, as Victor established earlier. So monorepos, what's the point of monorepos? Well, there are 3 things that I'll show why monorepos are great. One is the atomic changes. So having atomic changes and flat history. And if we look at an example here of an app where we have a homepage app, and it depends on a common UI library, and these are both split into 2 Git repositories. And then we spot a bug in the common UI repository. A typical process might look like this. As a developer on the common UI repository, I'll write a regression test, I'll write a bug fix, and then I'll open a commit or a pull request or a change list, depending on what you call it. I verified locally the regression test is satisfied by my fix. I push it to CI, and the test passed, so I merge it, I tag it, and then I go home for the weekend. I go on a vacation because I'm happy that I fixed something and I deserve it. And then next Monday, then the homepage app team comes in. They see I've tagged a new release, and I said that I fixed the bug that they reported. And they write their own regression test and integrate the new change. And they push it to CI and see that their tests fail. And so what's the problem with this? Oops, let me go back. Didn't mean to progress yet. So what's the problem with this? The problem is that now me as the guy on the common UI repository team, I've left, and the change didn't actually fix. And now the homepage app team has to go back and figure out why it didn't fix, get someone else to work on it, wait for me to get back from vacation so I can fix it again. When I've lost all the context, I've drinking a lot of Mai Tais and have forgotten everything that I did before I went on vacation. And now it's a lot more expensive for me to fix that change than it would have been if I would just got it right in the first place. So let's look at the same example, but instead of having 2 separate Git repositories, we have a single Git repository. So by having the common UI and the homepage in the same repository, we remove that step of publishing and versioning something and then integrating it later to see if it worked. We're actually integrating it at the same time. So we write a regression test for the common UI library and a regression test for the homepage app where the bug was initially reported. And immediately we see that if we applied the same fix we tried before, we see immediately, oh, this doesn't actually fix it. I need to work some more and change the common UI a little bit more to actually fix the regression. I fix it and update it, test pass, and I merge it without any of the integration delay and the wait in integrating it to where I can see that it actually failed. So now it works. I don't have any of those problems. So that's why just a quick example of why atomic changes are important. But let's look at shared code. And let's say you have this validator that is checking that a username is valid. If you wanted to share this code in a poly repo, like multi-git repo setup, you would have to set up a new repository, set up the tooling, the build and test and CI for that repository. And then you'd have to set up publishing. And also along with publishing comes versioning and what your guarantees are about changes and breaking changes. Those are all things you have to figure out anytime you set up a new repository. But if you have them in the same monorepo, in the same repository, all you have to do is create a library, and that's it. You've got all the build tooling set up already. You've got the CI that's set up. You don't need to publish because everything's depending on source of everything. So no versions are necessary. And anytime you make a breaking change, you just fix whoever depends on that change, and you don't actually break. You just change your API and change whatever depends on it. So that's why monorepos make shared code essentially free for what was complex before. And third, we have a single set of dependencies. And so one thing is that there's this thing called the diamond dependency problem. And so that means, so when you have a library or a project that depends on two other projects, and they depend on the same version of another dependency, that works fine. But when you get into issues, when you have two libraries that depend on a third layer, sorry, let me back that up. So you get into problems. So when you have a application at the top that depends on two libraries directly, and they depend on a third-party library at the same version, everything works fine. If you have something where you depend on different versions of that third-party library, then you get into a point where you end up having to have two versions of that third library deployed. And this gets into a real problem with JavaScript applications, or really anything that has instance of checks at runtime, like Angular. If you have different versions of Angular inside your repository and they get bundled together, then it's not going to recognize other versions of Angular when it does instance of checks or other, in addition to having performance issues of having multiple Angulars included in your bundle. So I didn't do a great job of explaining that, but there are good articles on the diamond dependency problem that you could look at to understand that a little bit better and why having a single version of everything is better. So let's look at some of the downsides, the typical downsides of when you have code living in the same repository. So one is that you run unnecessary tests. If you have many things in the same repository and you're testing everything every time, that can get expensive. And if you have no boundaries between code, we'll look at what that means in a second. So running unnecessary tests, if I have this product's homepage that's shared on depends on a shared product UI, so that's a library, then those are only two things in this workspace. If I touch the shared products UI, I don't need to test everything else in here, but if you have a naive setup, that's what's going to happen. You're just going to say, how can I know what needs to be tested? I'll test everything every time, which is bad. That's going to take a lot of time. Build time has a big impact on team productivity. And so the next is that there are unclear or non-existent code boundaries. So if you have some function or utility that you've written just for one part of your code base and you don't really intend to support that for other people who use it, there's nothing stopping people from just going in and importing it because they have access to all your source, and they can just import it and use it. And then if you ever want to change that, then you have to work with them to either say, okay, I'm just going to delete it and you're broken, or like update it or just create a new version of it because you don't want to change the old one. And then you've got more code and it's harder to maintain, et cetera, et cetera. So that's one of the typical downsides of code co-location. And then you have inconsistent tooling. So if you have a bunch of different constraints on your builds, and there's no kind of coordination or no kind of standardization on how your scripts are run in the repository, then you just end up with a bunch of different scripts that you have to figure out which team is building what in what ways. And if you ever want to change something else or you depend on something else in your repository that you need to run, then you have to figure out all the nuanced, all the servers they have to set up, the proxies, and whatever else needs to happen to build it. So there can be a lot to figure out. So these are some of the downsides of naive code co-location. But let's take a look at how NX deals with these things. So if you're not aware, NX is an open source toolkit for monorepo style development. It's built off of Angular CLI. So it's very similar to Angular CLI, and actually it was totally compatible with Angular CLI. So it has the code generation. We add some additional support for additional tools for you, like Storybook, React, Prettier, Cypress, Jest, like modern tools that most teams are gravitating towards for testing. It's also extensible, so we have features where you can generate workspace schematics so that your team can have consistent tooling and easy ways of doing common things without breaking or without doing things differently. And we have a unified experience for front end and back end. So we have just as much support for Node servers like Nest.js, Next.js, Express as we do for front end. But one of the key things about NX is that it understands your project graph. So it actually understands how your libraries and applications inside the workspace relate to each other. And that's what it uses for most of the advanced tooling that it provides. As I mentioned, it's open source. It's free. Like there's no like restricted enterprise version or anything. It's like totally free. We build it as we see new needs with the clients we're working with and the community. And it's been a great thing for us as a company. We do a lot of consulting around it. So in training, so it's worked out pretty well without us ever having to charge for it. So what it is, it's basically breaks down to its code partitioning and intelligent tooling to develop at scale. So we've got an example here of like you can have, and this is to show that it works just as well with React as with Angular. A lot of teams have Angular and React in the same workspace. So apps and libs are the main building blocks of NX. So let's get a little bit more concrete and see what it looks like in practice. So just like creating an Angular CLI repository, you would start by creating an NX, or not a repository, an Angular CLI project. What would you call Angular CLI things? Workspaces, I guess. So you'd start by running this command. Just running, you don't have to install anything before this. You just run npx create an X workspace. It prompts you to give it an org name, and then you can use a preset like Angular or React, and then it will create an Angular app for you. You just name it, assign your CSS, and there it goes. So basically the same process as ngNew. Of course, npm install is the slowest part of anything. Okay, so that is, let me see. Forgot to fix the timing on this. So that's the quickest way to get started, just running that script. You don't have to install anything beforehand because you're just using npm's script execution. So next is creating reusable libraries, and libraries are the main way of partitioning things in NX. An app is something that gets deployed somewhere, and a library is something that can be depended on or can depend on other libraries, and allows you to partition your applications in a lot more logical ways. Even if it's not something that's shared between multiple applications, libraries are a great way to partition things within your application. And this is also one of the key things to realizing some of the performance benefits of improving build times later. So here we've created a library that is a UI library and just has the Jest configuration. And then once we have libraries, we can add components to that library. So using the same like schematics, just as you'd be familiar with Angular CLI. So we're using the Angular CLI schematics, the Angular component schematic here. And of course, using NX console. If you don't have NX console, this actually works with NX workspaces or with Angular CLI workspaces. It's a Visual Studio Code extension, and it adds a UI, or a lot of, not just a UI, but a lot of IDE benefits of working with Angular CLI or NX, so that you don't have to remember flags. You can quickly run commands. You can explore your projects. So that's as easy as it is to add components to a library. There are all these other things that NX does we're not going to get into today. I encourage you to check out nx.dev. That's the home of all things NX. but we want to now focus on how NX makes builds fast. And I'll let Victor take over from here. And I'll keep
I'm going to not, yeah, because I don't use Mac, so and iCloud, like in the browser, it's a disaster. So it's not.
I would imagine.
So it's not working, you know.
All right.
Okay, cool. So
I'll keep the time. If you see me exit it and stop it, that's because there's auto timing, and I just need to pause it. But you can just keep going.
Yeah. Let's blaze through the presentation part, and then I just want to show something in a.
Okay, we'll blaze through, and then you do some demos.
Yeah, I'll just show some my projects, like I'll share a screen, and I'll talk through some stuff a bit more in depth. Basically, the idea that normally you would have one application that you would build sort of as a unit, but when you build it with an X, right, you don't have one application. You usually have one application composed out of a bunch of libraries. So in this case, we have an application that has 4 libraries that it's created from, right, and a normal size NX app. So if you use NX well and you use it for a while, you tend to split your application to way more libraries than 4. Okay, but in this example, 4 is good enough. And once you do that, you'll realize that there are certain things you can pull out, right, and build and test, etc., in isolation. And the common things are like validators, some basic rules or utility that you can share across teams, across lines of business, across applications. And another very, very common thing that almost all large organizations do, even small organizations, we have a design system internally, even though we are an organization of very few people, is building a design system, like a set of components that can be built independently, but also can be used sort of in a very in a way that you use material components, for example. All right. The design system in this case in particular is very interesting because those type of things can be very complex. It can be very hard to manage, very hard to build. And that's why, for example, we added support for things like Storybook, right? Because Storybook is a fantastic tool to do design system work, right? Much better than trying to do it with, say, Karma. Next slide. Okay, cool. Now imagine we have this application with a bunch of libraries, and a developer, maybe Jeff, changed. Let's see what's in the chat. Okay, cool. People ask him to speak slower, which is fine. So let's say Jeff changed the new ticket feature, right? And the new ticket feature, submitted a PR, changed something in there, right? Normally, the way you would do it, if you don't use an X, or if you use an X incorrectly, right, you would rebuild and retest everything. And that works, like redoing everything. That's a very simple mental model, right? That in principle works, but it had a downside. It's been very slow. So in this case, if we do it and we naively rebuild everything and retest everything, right, we are going to spend a lot of time, right, validating our changes, right? And obviously, the point of a monorepo is that you tend to build either large applications composed out of different modules in it, or even multiple applications. So at some point, that obviously stops scaling, right? It becomes sort of hard to manage, right? You're going to get very long local builds, very long CI runs, etc. Next. And so the first thing that we landed, that was the original key feature of NX, right? Is the code change analysis feature, where because we know the project graph of your workspace, we know how different parts of your workspace are wired up, how they depend on each other. We deduce this information automatically. You don't have to tell us anything. We can derive it by just looking at the source code. And if we derive it incompletely, you can augment a few things. So I would say maybe like 97% of the edges in this graph we figure out ourselves, and the last 3% is what you have to manually configure, right? So the maintenance of this graph actually is relatively low, right, given how much work we do. So, but once you have this graph, it's not hard to realize that we know that if you change a new ticket feature, next slide, the only part that requires changing or requires validating, right, is a new ticket, next slide, support ticket, and the app itself, right? So we don't have to check the live chat app or the knowledge base because they cannot be broken, right, by this change. So that is the first idea. So we looked at the code change itself. Basically, we look at the git diff naively, right? So we look at the git diff, we analyzed it, right? And we redid only a fraction of the work. So in this case, instead of retesting every single project or rebuilding every single project, what we are doing is we are retesting and rebuilding a subset of the graph, like very few projects, good performance savings. So, and how much you save here really depends on the type of change that you make. It really depends on what type of change that you make, and it really depends on like how many apps you build in a repo, etc. So that varies, right? But for, I would say, for mid-sized repos, for repos that don't do very much, most PRs tend to affect a small part of the graph, maybe like 20%. And the larger the repo is, the smaller this number is, right? Because you don't tend to change everything in the repo. Right? And obviously, so that's one part of making your build and test perform. The other part is parallelization, right? NX allows you to parallelize stuff very, like on the same machine, on the same node. That works very easily. Just pass a flag, grant everything parallel. It also allows you to build in a distributed fashion on many nodes, which is, I will talk about in a second. But anyway, so parallelization. Next slide. So as a result, what you are ended up having is the slowest part of your build, or the slowest build you're running, right, is your total CI time. Right? If you have an app that takes, I don't know, 10 minutes to build, well, you can make your CI time 10 minutes. It cannot be faster than that because in this case, it's an indivisible piece of work, right? You have to run the 10-minute thing. But you can at least say, okay, 10 minutes, this is the limit, right? Which is pretty good. Next slide. The thing that is interesting here is that, so like, how can we make that 10-minute, that indivisible piece of work smaller, right? If it's a single operation we have to run, like it's one Webpack build that builds everything from source, we cannot make it smaller, right? That's it. 10 minutes is the limit, which may not be a problem on CI that much, but it's more annoyance when you do it locally, which I'll show in a second, right? Where if you have to wait for many minutes to serve your application, that sucks, right? That's not a very good app experience. And if you build in a very large application, right? If you build in a massive app, it's not uncommon to wait for 5 minutes for your ngServe to show up, right? 5 minutes is a lot of minutes. So when you kill your ngServe by accident, you get really frustrated. So you have this fear of by accidentally closing the terminal because you're going to waste 5 more minutes waiting for it to like reappear again. Next slide. The solution to this is to allow for incremental builds. The idea behind incremental builds is that when I want to serve my application, for example, or build my application, I don't have to redo everything from scratch every single time. I can do different parts of the serve at different times, right? And then when I serve my app, I will only redo the part that I need to redo, and the rest I'm going to reuse, right? So in this case, imagine that validators and the design system libraries can be built and packaged in advance, right? Such that when I boot my, or do something with my ticket, right, and serve my app, I don't have to redo the work regarding validators in the design system, right? And that's the idea behind incremental builds. In this case, what you're basically saying is that my ngServe or any operation I run, it doesn't matter how big my app is, by and large. I mean, of course it matters a little bit, but you know, it doesn't matter as much how big my app is. What matters is how big is my change. So if I pull master and I serve my app, because I have no changes compared to master, my serve should be close to instant, right? Maybe take a few seconds to do something, right? But if I like change a particular one library, well, I need to redo that library. So my change should be relatively fast. Maybe I should wait a few seconds, right? But if I change everything, then yes, that may take a long time, right? That is the idea, right, behind incrementality, that we want to make sure that the operations we invoke are proportional to the size of the change. And that the whole idea behind NX in general is just some things like Webpack were hard to break that unit, right? A single ng build was very hard to split into two. And like now we can't split. Then we'll show you again after the presentation is over. Next slide. So with incrementality, what you get essentially is the fact that some part of the computation that would have happened before doesn't have to happen because we can retrieve it. It's stored somewhere, right? So in this case, the total time we have can be this or can be even smaller. If you don't make any change, it can be close to 0, right? So that's sort of the idea behind incrementality. And for this to work, for incrementality to work really well, what you need is the ability to share your computation with your teammates. Right? If everything you have is happening on your machine, on everyone's machine, if you have a coworker and she runs stuff on her machine, And if you don't share your machines, that can still be very valuable because you can, like, every build is incremental as insofar as whatever your machine has seen. But if you share it, suddenly most of the builds you perform, will only have to rework a small part of the code base. Next slide. So in this case, you can just blaze through the slides. Next slide. So the tool we have to enable that, now I'll show you again how what it does in a second. It's called the nextcloud, which is essentially a way for you to share your computations with your teammates. Next slide. So with this, if you have that, suddenly, in this case, the nextcloud section is basically a cache section that came from elsewhere, right? It came from other machines, right? Someone else ran. So it's still cached. It's not your machine that performed the initial computation. It was someone else, maybe your CI, maybe your coworker or whatever, right? So things like that. And with that, you can really reduce the build time to almost nothing. So most operation that you run, unless you're actually performing like a wide range, like a giant refactoring or whatever, right? Most operations that you invoke have to redo a small part of the computation that they would have had to do before. So with this, right, if you look at this, those bars, of course, is like pseudo data, whatever. We don't know what those bars correspond to, right? But it's not unthinkable to imagine that going from a naive workspace situation where you can actually wait for like 10 hours to validate a PR. If you have a large workspace and if you do it naively, 10 hours would be the time, right? If you go to effect, you can reduce it to maybe an hour or something like that. But if you push it down, right, you can reduce the average time of your PR to just a few minutes. Next slide. Yeah, so the CI in this case is something that, again, show in a second when I actually show you a real project, can be reduced by 10x with some caveats in that if you have like a 20-minute NPM install, well then, obviously nextcloud is not going to help that, right? So you need to address some other parts, right? Maybe differently. If you want to really reduce your the average CI time to, let's say, like a minute. But like a 10-minute CI time or like a 7-minute CI time, it's very realistic without having to reinvent anything, right? By just reusing computation from previous ones. Next slide. Yeah, so in this case, we're just showing that developers and the CI can share the same cache so they can collaborate. And so it's not just one developer doesn't have to rebuild something another developer already built. The CI and every CI agent is a separate code, like developer, right? Every CI agent is a separate context. So being able to share stuff between different CI agents can be a big deal as well. Yeah, so can I share my screen? And I just want to, I want to walk you through some sort of a real project, so you can see how easy it is to make it work, and I can talk about some stuff a bit more in depth in this case. Okay, so where are you? Okay, I'm going to share my screen. Don't be alarmed. Okay, can you see my screen? Okay, cool. So I have a small NX workspace, right, with one app called Shop, and oh, great. Let me try again. Suddenly, my computer stopped collaborating. Just give me 1 second. What I want to show you is basically while everything is loading is two things. Is like this sort of the basic example of like what it means to share computation, which is well and good, right? And then I will show you like an advanced example. Like if you have a very large app, what happens then? Let's see. Projects. Okay, maybe this is good enough. Okay, let me see. Let's try again. Okay, can you see Same workspace, different editor. So the Simplex Workspace has an application in here, a plain application, nothing interesting about it. Right? So if I do something like an X build shop app, right? And an X build and a G build are almost the same, except one thing that I will show you in a second. That is important. Right? If I do an X build shop, all right, and if I do it the first time, what is going to happen is I'm not going to do it in prod because it's going to take forever. So I'm building this in a fast way, right? So we don't have to wait. The idea behind come on. This is actually a great example of why a computation cache can rock. So it took 20 seconds to build it, and this is a dev mode. Prod mode will be a minute, right? So so I build this app, right? If I run it again, right, the result will be instant, and I will see this this note saying that it has been retrieved from cache, right? So any operation in X works like that, right? If you're using a newer version of an X, if you're using 8.12, you can opt into this, right? If you're using an older one, there is a very easy way to make it work as well. So every operation you run, build or test, doesn't matter, right? Will be retrieved from cache. The way NX does it is it looks at the source code, not of your whole workspace, but of the parts of the workspace relevant to the operation, right? So it knows because it knows how your workspace is wired up, it can deduce which part of the workspace it needs to look into to see what's relevant to the operation. It looks at that. It looks at what you're trying to do. For example, NX build shop is different from build prod, obviously, right? So look what you're trying to do. And it looks at the environment. For example, maybe your OS, you can provision what it means for you to have the environment. OS, version of node, things like that. It takes those three pieces, right? And it creates a unique sort of value for computation. And then it checks locally, it's like, have I computed the same stuff before, right? And if the answer is yes, instead of recomputing it, which we know takes 20 seconds in this case, it can show you the result instantly. And it doesn't just print it. It also, if I remove dist, right, and I run it again, as you can see, the dist folder got populated correctly as well. So it places the files where they should be placed, and it replaces the terminal output. So for you, the result is basically the same, except you see this, node that, hey, which we assumed the result is the same, we replayed it correctly, right? We didn't compute it, we retrieved it from the cache. Right? So this is the idea behind computation cache in an X in general. By default, it works locally, like on your machine. So if I run it twice, as you can see, the second time is free, right? And it works locally on your machine. That's the important part. Another important part to note here that its computation cache is different from like an artifactory, right? There are no versions here. We're not pushing anything to some artifactory to say, this is version 1.0 of this app we're retrieving. No, there are no versions, right? There's simply, a better way to think about it is like how Git works. When Git has a SHA, right? The SHA corresponds to some state of your repository. So when you can uniquely refer to the state using the SHA, right? This is somewhat similar, okay? So this is computation cache that works with for any operation. If I do the same for testing, I mean, testing tends to be quite fast because we use Jest, but in some cases it can be, again, it is much faster when I run second time. In some cases it can take a lot of time, right? Especially if you have integration tests that are very heavy, right? So that's the computation cache. The problem with just doing that is if Jeff wants to build the same shop app that I've already built, he cannot benefit from my building. He has to build it himself. So we basically have to recompute the same thing many times. So in this simple setup, what we get is never build or test the same code twice on the same machine, right? So on the same machine, on the same laptop, I never have to redo the same work again, right? Which is good. But we would like to share this work across the team, across the org, or if it's an open source project, right, and you use an X for that, across the whole community, right? And to do that, what we need to do is, can you see my browser? Okay, cool. What we need to do is we need to connect, just zoom in a bit, this repo to a distributed cache, right? And I can just do that. And I can do it like this. You see, I tried a bunch of things. Then are two. I just need to basically copy this command, right? I need to see if I'm using npm. Okay, I use npm, and I need to run it. Right? So if I go now over here and I invoke this command, what I'm next going to do is going to install this package, the next cloud package, and it's going to update one file to basically say if you couldn't find anything in your local cache, look over there as well. Okay, let's clear it. Okay, so now nothing else is required. That's it. So you need to run one command and you connect it to the remote thing. So the difference here now, so between what I had before, right, and what I have right now is that let me delete my local cache, right? So I start from scratch as if I just pulled this repo, right? If I again build my app, it's going to take some time because there is no local cache, right? It will take 20 seconds, right? And that's the problem with local cache. This is basically either might be in a different person, or maybe on a different machine, or maybe this is a CI trying to build it, right? Has to redo it. That sucks, right? And again, we have to wait. This is actually like the waiting, like how long it takes Webpack to build is like an advertisement for computation cache. You don't even need to do anything apart from like, that wait was too long. Okay, this is actually, if you run it in prod, Jesus Christ, that's going to take forever. So if I run it again, this is local cache, right? As before. But now imagine I'm Jeff, a handsomer version of Jeff, right? A more handsome. So so I'm Jeff. I don't have local cache anymore. So I just pull the same repo. And how can I, benefit from having Victor as my teammate? Well, one way to benefit is let Victor compute a bunch of stuff. So when I try to compute it, what happens is, Jeff, in this case, would get results instantly. Again, replayed, all files will be in the right place as if you ran it locally, but from a distributed cache. And you can see the result here saying, hey, we got it from a Nextcloud, right? So this is not a local cache hit. We got it from a remote location, right? And if I run it again now, in this case, second time, it doesn't have to go anywhere because now it has it locally, you don't have to hope across the network to find the artifact, right? That's the idea behind distributed cache, and that when you can find it locally, you can find it elsewhere, right? And your teammates, your CI can share the same location where you can, get the caching artifacts or like the computation artifacts from. Right? Again, it works for build, test, or any command. It's not build specific or anything, right? Very different from artifacting in this way. We're caching computation, not files. Okay. So what that happens, and now what I have here is a very simple project, right? Just a single app. And you can say, well, if I have a single app, how useful is that, right? You could say. And because like, I'm never rebuilding the same app twice, do I? Like I do it very rarely, right? You could say. But the answer is actually, you don't do it very rarely. It's surprisingly many times, the same thing gets rebuilt over and over and over again, right? The example would be, right, your CI, when you send a PR to your CI, to like, I don't know, Jenkins, right? Jenkins would run your PR, build and test stuff. And even if you use affected, let's say you use affected, you only rebuild 20% of your workspace in that PR, right? Then you have to rebuild this PR again because someone asked for like a small change. Or maybe you have a thing where you have to be up to date with master. So you have to rebase and rebuild it again, right? Anyhow, so you have to rebuild the same PR again. And in many organizations, the same PRs have been built gazillion times, right? Sometimes 20 times before they land at the master, right? Then it merges at the master. Presumably, whatever you merge into master has been tested in your PR, so chances are it's the same or very similar, right? So things like that mean that a lot of runs you do in your CI redo the same computation over and over again. And it's not just twice, often dozens of times, right? Dozens of times. So if you enable, and even though you have sort of computation that's not very granular, like building an app in this case is not a granular computation, it has to rebuild the whole app, right? Even that alone can reduce your CI time, like substantially by a factor of 3, for example. Because most of the time, when you're rebuilding this app, you can just say, hey, I found this exact build before, I don't have to rerun it again, right? That's why it's not it's not something that could be replaced with like affected, right? Because from the affected point of view, from the code change analysis point of view, every time you build your PR, same app has been changed, right? The shop app in this case, it's changed every single time. No difference, right? What is different here is that the second time I run my PR, the computation would be rebuilt, right? Or like it would be reused, right? And as a side effect, the nice part about it is if you like send your PR and you have like 100 libs there that affected, and like one of them failed, and you go back and you're like, oh, you know, now I have to like copy and paste the libs that failed to run them locally to troubleshoot. I don't like copy and pasting. I always make that, you know, like it's all those type of things, the small annoyances that make my life a little bit worse. You can always do things like that and say, I actually want to target test, retest everything. I mean, in this case, it's not much of an example because but the idea would be that if I like CI just tested my thing, right? And if I do it again, most of my tests would be instant, and only the one that failed on CI would be rerun locally, right? So I don't have to pick the project that I need to attend to, because whatever was successful on CI would be instant on my machine. Whatever wasn't successful, I have to redo anyway. So I don't have to copy and paste stuff. I can always think about my repo as like, I can redo everything. Redoing everything becomes very cheap because most of what I'm trying to redo has been done already, okay? So now let me show you something that is much more interesting. This is a very basic repo that basically says that even if you have a single app in your workspace, right? One application, or you have an Angular CLI workspace, and if you move it to an X with a single app without doing any refactoring, by just connecting to the cloud, you can get some benefits in there. But the real cool part, like that, is a game changer for sort of larger projects where you sort of have no choice. Previously, rather, you would be screwed. Is something like this. Okay, so I have a repo here called Incremental Large repo, right? And what it has, and what I have in this repo is two applications, app 0 and app 1. They are the same, except they're wired up differently. All right.
We should, in 1 minute, we should move to the QA portion.
It will be super fast. It will take a minute, more or less. And each of those apps is composed of many, many libs. And each lib has a lot of components, okay? So those are very large apps. App 0 and app 1, by very, I mean somewhat large apps, right? So if I pull my, try to run one of them, let's say I'm doing ngConf app 1. What is going to happen is ngConf is the same. Again, ng and nx is the same, except nx adds caching. Everything else works exactly the same, identical. So when I'm running the surf, it's going to take some time. And as you can see, it will probably take, I don't know, a minute or something. Let's wait. I just want to show you the difference so you see why incrementality is so key, right, for large app. This is not even a large app. This is just a moderately sized app, right?
By the way, let me do a plug for nx.dev because we're going over a lot of the cool, like what the experience is and what the output is. But if you want to understand how these things work in more detail, we have good guides on nx.dev. Like if you look in the CI section of the docs, and it talks about incrementality and caching in more detail. So it's less
exactly. Yeah, it's a good point. Yeah, check out nx.dev. There are a lot of, we revamped a lot of guides, tutorials, updated videos. So there is a lot of fresh content there that reflects the current state of it. Okay, we're still waiting. Look how bad, this is basically a typical web app experience, right? Like you have a moderately sized app, you can, go to the washroom and come back and will still be serving your app, right? This is not a very good experience. It will take forever. Without Zoom, right, that eats all my CPU, it usually takes about a minute. But now let's say I serve my app 0. How long would it be? Oh, shoot, what? Okay, just give me 1 second. Okay. Demo error. That's because VS Code loads context. Anyway, I don't want to explain it. Just give me 1 second. Projects, examples. Sorry. Okay, let's try again. Okay, same app. again, if I do an XOR of F1, we're going to sit here till tomorrow. Okay. So, but if I do the app 0, it's going to be a bit better. And so it's going to build the same app with all its dependencies smartly, and it's serving. It took a few seconds, right? And the important bit here is that if I already had local cache, that's why it was so fast. But if I remove my local cache, right? Let's say I'm Jeff, and I do the same, the result will still be pretty good. It will take a few seconds because this is a large app. It's lots of large components that it has to fetch. And now it's running. And the second time I run it again, it's faster. So basically, we reduced our time from without Zoom, when I actually have my CPU running well, from 1 minute to about 4 seconds. All right. And the idea here is that if the size of my application basically doesn't matter to how expensive initial server is, right? The size doesn't. What matters only is like this initial server should always be about constant, you know, just a few seconds. And then if I make a change, right? If, for example, I change the library locally, well, then the cost of this change, the time I have to wait, is proportional to the size of the change, not the size of the application. It is not exactly true in here, you know, because I still use Webpack under the hood, but it's more true than ngServe. So it allows you to actually serve substantially large applications. So if you have an ngServe right now that takes 10 minutes or 5 minutes, I can guarantee you that by spending, I don't know, an hour and converting to something like, an hour would be, but by spending some time converting something like this, right, which is not that difficult, you can reduce your initial ngServe from 5 minutes to, 5 seconds.
So that, at least you took 5 minutes, but at least you answered one of the questions with that demo, which was, does NX caching work with ngServe?
Well, that is a good point. Let me actually clarify this. The ngServe in this repo, which is a public repo, and I can share it with you, is done differently because Webpack dev server doesn't work with caching well. So I had to, when I still run an ngServe here or ngServe, because you don't, as a developer, you don't care what serve does, right? You run an ngServe, does something, right? But I'm actually doing something else here. I'm building my stuff, and then I'm serving the folder, right? So I do something else in there. It's sort of a naive way to make it cache friendly. There are less naive ways that are even more performant than what I'm showing to make it cache friendly, but this is a naive way. So if you have a small app, if your engine sort of takes 20 seconds or like 30 seconds, okay, maybe don't bother, right? You're in a fine spot, not a problem. It's more like when you go into many minutes, then you can say, maybe I have to abandon the default Webpack way of doing it because Webpack just doesn't scale that well for large apps, right? It's sort of not, it's usable, but it requires you to sort of abandon some of the more common ways of using Webpack and just tweak it a little bit, right? And this repo that I have is called NX Large incremental repo. Large is the key part, right? It shows how it's not super hard to do it. If you can do it really well.
Maybe you could post the link in the chat.
Yeah, let me post the link in the chat. I encourage you to look at it if you build in a uber large app, right? If you have an app that is like, you feel like the dev experience is not very good because it's so slow, well, I mean, it's actually not super hard to make it reasonably well performant. There you go.
Mm-hmm. All right, okay, cool. And yeah, a couple more questions. I'll recap some of the ones that I answered and Victor answered over text first.
All right.
So yeah, there was a question about if NX supports microfinance, which we have a great blog article for. So right. Check out the answer. With the blog article, it focuses on React, but there's nothing really React specific in the article. It was just that we were getting asked from more people in the React community about it at that time.
Can I add one point to this? It's not just NX supports micro frontend or like micro frontend is a very loaded thing, independently deployable units, right? Mm-hmm. It's like monorepos actually make using micro frontends a lot easier. Mm-hmm. Micro frontends have downsides, and this article sort of touches on that a lot of those downsides either go away, become a lot less severe if you have a more sophisticated build tool like NX.
Yep. Yeah, we've got clients who are using that in production, and it's working out. I mean, there are challenges to it, mostly, but the challenges aren't related to monorepos. It's related to how you share things in your deployments and how you know how to what needs to be redeployed, how you constrain your team to be able to do more incremental deployments. Another person asked if we have integration points with .NET Core, which is being worked on. At least it's in the proof of concept phase right now with our team.
Yeah.
Definitely something that's important to us, though. And you
no, I agree. So
already.
Yeah, so that's the important part. That basically there are different experiences you can have with NX. The basic experience of like, okay, my caching works, effective works, the basic stuff works. That works with any technology already. It's like NX, all the work that NX does over there is sort of process oriented. So as long as you can spawn a process, it can be anything. Okay, so .NET Core, Java, Go, doesn't matter. The next level of experience is, do I have like a good collection of schematics I can use to generate artifacts? Like, did someone, because right now we don't. So you have to, either author files yourself or like create your own schematic. So that part isn't there. So if you have a few apps that you want to just manage yourself, that will work already. You don't have to wait for anything. But if you're thinking, okay, I'm going to create 100 .NET Core microservices and I need a lot of help with schematics and stuff. Okay, maybe, like you have to put some work into making that experience good.
Exactly. Another one asked about integration with Azure DevOps, and I just posted a link in our chat that has an integration with that. It shows off parallelization and affected builds, but it doesn't yet have incremental builds or caching in it. That's probably something we could update soon to connect it with NX Cloud, just to show some of the more recent improvements.
Yeah, I agree.
Someone asked about NX support for Bazel. The short story is like, we have a storied history with Bazel. Victor and I used Bazel quite a bit when we worked at Google and liked it. And actually originally we're building NX as something that was built on Bazel, ended up backing off that, mostly just because Bazel was pretty rusty. And, it's come some way since then. But NX now supports a lot of what Bazel does, just in a different way. So like incremental builds, caching, parallelization, those kinds of things. It's done in a way where NX already understands how your projects relate, and so it can do a lot of things automatically that you don't really have to configure like you would with Bazel. So there's for teams who need more granular control and need support for languages that Bazel supports, then it might make sense for them. And so that's kind of why there were people working on it and we were supporting them. But I think that effort may have slowed a bit.
Yeah, and the reason why it's slowed is basically Bazel has some like really good properties, right? And we essentially with our cache and stuff, we try to like implement sort of the 80% that is good enough for pretty much everyone, right? And may not be 100% as efficient in some situations, but it's close enough and it doesn't require you to configure anything, right? But the thing is basically that, as with any technology that was developed internally at a large company for like 10 years, right? And it was tailored to the internal customers, right? So for 10 years, it's very hard to make it palatable in a broader, like a work in different scenarios, right? It's not the same, but if you look at the closure compiler story, it was kind of similar way to work. It still works perfectly well internally at Google for a lot of projects, right? And one can argue, optimize this bundle better than say Webpack does, right? But it's because it's so challenging in terms of how, like, it's kind of hard to use, right? It didn't really, like the trade-offs aren't there. Like to get this like 5% improvement, you have to really struggle, right? To use closure compiler or whatever. And with Bazel, I feel like it's somewhat similar in that if you are able to make it work in your organization, and maybe you already have Bazel, right? Stick with it. But the act of making it work is actually it's challenging. Like very few organizations are able to do it. We had different ways we could integrate with Bazel. One of them is we still have it, right? Where we use the new Bazel linker to invoke binaries, from NX. In this case, NX does use Bazel. But I honestly feel like the number of people for whom this is beneficial is very small, right? So if you are one of those people, feel free. We have a package, you can explore it, whatever. But it's like something about your organization has to be unique for it to be worthy. For example, you already use Bazel. Okay, if you already have a lot of Bazel expertise, that's great, right? Sure, you can use it. If you don't have Bazel expertise, it might be a bit more challenging than you might imagine to make it work. And from what I understand, the Angular team kind of removed the Angular CLI Bazel integration and the docs and stuff, or removing it currently, right? There is a PR open, because it's the market for whom this is useful is very small.
Yep. So yeah, like Victor said, we're big fans, and like and a lot of what's in X is inspired by Bazel. No denying that. So we just done our own twist and giving it much of the value. And so it's really those people who need that last 20% of control that.
I would say, like, I'm a big fan of many things. Are you like Haskell? Do I advise everyone to use Haskell to write the applications? No, right? So think NX has been TypeScript to Bazel being Haskell, right? Where maybe conceptually Haskell is better in some ways, right? But it's a challenge. It's not a tool for everyone, right? If you can use it, good for you. Most people can't.
So we're a little bit over time, so I'll just recap a couple of the other questions on here. Yeah, someone asked if there's an on-prem version of NX Cloud, so we're working on a private cloud version of NX Cloud. Just shoot me a note at jeff@narwhal.io if you want to get notified as that becomes available. We're working on summarizing that and putting together some info to send out, and some of our customers we're working with on setting it up. So that'll be something soon. We've gotten a lot of demand for that. Another person asked about React and Angular in the same monorepo. Yeah, lots of people are doing that. You can share code.
Yeah, it works really well
between them.
Can I add a quick point there? So
okay.
React
10 seconds.
10 seconds. So the NX can work as an Angular CLI with Angular CLI. We used to use the Angular CLI, or it can work with its own CLI, which functions basically very similar to the Angular CLI. So which often is the case where you have like a mixed workspace where you have React, Angular, a bunch of Node stuff. Some people, like React people, may not be happy invoking NG for just emotional reasons. They're like, something about it just feels wrong. So you can use a different flavor. The Angular people won't even know the difference. Okay, one character is different, the rest is the same, right? But everyone else will have to see Angular every time they try to build a React app. Maybe,
the other difference is that we have the workspace.json instead of angular.json to configure your
yeah, exactly. So it's
if you want, you can still have angular.json in X workspace.
Yeah, exactly. So that's just to think that if you have like a 50-50 split, right? Consider that option.
And someone just asked about Gatsby app, and that's something our team's working on first-class support for.
We have a package already that works. We don't publicly talk about it too much. We just like battle tested it to make sure that when we talk about it, it actually works for a lot of folks, right? In the React world in general, we have support for the React itself, right? We have really good support for Next. It much improved now. It works like really well. I enjoy using it. Gatsby is another piece that's coming. It already came. It's there. We just don't talk about it right yet. And React Native is going to come in sort of maybe at the end of summer or something like that. We already had some spikes. We know that it works. And so it's going to happen later.
And someone asked about Scully, which I imagine is, the Scully team uses NX and we are great friends with them. So I think it's a matter of time before there's official. I don't know that we need to add much for Scully, to be honest. If they have schematics, and I'd have to.
Yeah, it should just work. So.
Yeah, we use the same schematics API and everything. So, and Angular Universal is the same. Like you can use the universal schematics in NX. I know people are doing it. I think it works out of the box. I don't think. I think the universal schematics
out of the box.
Are enough that they don't assume the Angular CLI layout. Okay, all right. I think that's enough. Someone also asked about Ionic, which there's a community plugin for that seems pretty good. We aren't currently working on first-class support for it.
Well, can I add one more point? Sorry,
okay,
I know we're over time. The thing is that we're trying to make a next really like a pluggable, like a VS Code of build tools or whatever. I don't actually use VS Code, but VS Code, because most people think of VS Code as something you can just put plugins in and it works, right? And we have a special command called create a next plugin that creates a layout for the plugin, so you can author your own plugin. So if you have your own technology that you want to add support for, like add schematics builders and add end-to-end tests for those schematics and builders, we have really good support for that right now. We can do it. We have a video that walks you through it, like a funny video, like with humor and stuff, right? We have a good guide. Once you have it, if you send it to us and it's high quality, you will be added to the community plugins page. So if you're interested in authoring a plugin, for your favorite technology, talk to us. We have a special Slack for people who also plugins, right?
And
basically,
there's a page on, and if you go to nx.dev and click plugins at the top, then it shows like you can list the plugins to see what's available, and the plugin API is also being extended to allow even more cool stuff with NX. Someone asked if we could extend it, which I'll let Bravery answer that. If we could extend for a couple more questions.
You're more than welcome to. Yeah, if people are interested, go for it.
Okay, so. So let me see what else. Let me look at what we've already answered live. And Victor, maybe you have a hard stop, but
I don't have a hard stop. I'm happy to.
Someone asked about if NX produces telemetry and how it can be accessed.
You mean how long every build and test operation took and stuff like that? Or
yeah,
can you be more specific about what type of telemetry? The long story, let me tell you about some telemetry. So NX by itself doesn't produce or record anything, but if you add NX Cloud in this case,
you want to screen share NX Cloud or like the app or?
Sure. Let me see. Just let me make sure I'm screen sharing something that is
we talked a little. By the way, NX Cloud is something that it's something that there's now a tier for, like an ongoing free tier of NX Cloud, where you get several hours per month, 5 hours per month of free cache hit.
Okay, when you say now, it's now as of tomorrow. Today or tomorrow. But
so right now, if you sign up, you get like a 5-hour coupon, so you can try it out and see how it works. And how we charge for NX Cloud is we charge per hour saved. So we take the original time for running a command or running a task, and then we subtract the time from running it with cache hits, basically, and calculate that and calculate how much time you save. And it's just $1 per hour saved. And so so you get 5 hours of a free coupon now, but as of tomorrow, we just have an ongoing free tier. So if you have a small workspace that could just benefit from some of that build savings, then you can have ongoing. But in addition to the cache savings, and we're going to be adding more to NX Cloud. That was just the first thing that made the most sense to invest in distributed cache. But we also are building more robust analytics of workspace performance. Right now, it's focused on the cache, like the computation caching. Go ahead, Victor.
So, and basically, right now it's we collect more data. We collect quite a bit of interesting data. We just don't present in any meaningful way yet, which is coming soon. But basically, if you open a workspace, you would see that it's been used. You'll see something like this. In this case, let's say for the build, it will tell you that it saved 18 hours in build. So it still took 15 hours over the period of this time to build different projects in this workspace, but it would have been about 33 hours if the cache wasn't on. And you can go in here, and get, the results that you care about, and look at each individual project and see how every project contributes to total time, right? Not a lot of data provided, but this is something that we show right now. These savings, by the way, could have been a lot bigger. The reason why they're not that epic is because this is our internal repo, and I frequently push to master, so we don't rebuild anything many times. Okay, so we build everything once at most. Okay, so even for our internal repo, where we don't have these practices where we refine PRs for that long or whatever, we have substantial savings, as you can see, right? That's not nothing, right? But yeah, you have this data. This is the telemetry we collect,
but we've been, like Victor said, we've been instrumenting more to collect more interesting data, and we've got plans for how we're going to show interesting things that help you understand where time is being spent to a more granular degree in different environments, and also helping you to understand insights into how you can partition things better to take more advantage of
actually, can I show something else, which is I think would be pretty cool.
Mm-hmm. And we'll go just a few more minutes.
Let me see if I can. This is the thing that I particularly I won't say passionate about. The word passionate just irritates me, but I care about deeply. Okay, so which is, let me see if it works. Okay, NX boost. Basically, the problem I'm having with trying to help folks use cloud is that if something doesn't work, right? Is they're like, okay, I don't experience cache hits. It's kind of challenging to help them out and say, okay, so how can you make your build faster by reusing more computation, right? And the idea is that we should be able to tell you when you run your stuff, right? Okay, let's see. It's going to take forever. So I'm just going to talk through it because it's going to be much faster. But the idea is that instead of you're just saying, hey, we didn't find anything in the cache, you know, the end, right? There's nothing you can do about it. What we can tell you instead is things like, well, we didn't find anything in the cache, what you're trying to do. But someone else did something very similar, right? Everything was the same, except one file was different. We don't actually store the contents of the files, right? We just know like sort of the hash values, right? Sort of identifiers of the files. And we can tell you that if you're building your app, we didn't find anything in the cache for this app, but we found the cache result for the same build command, but someone passed this extra flag, maybe source maps false or something like that, right? We found that, right? So when you start like figuring out how to optimize your flow, especially in CI, right? You can look into those sort of debug information, right? That stuff to see that, to find those things where for some reason maybe different CI jobs do things very similar but not exactly the same, etc. Right? Or maybe you keep changing the same file, right? You may have incremented some version somewhere, right? And yeah, that is going to break the cache, right? So the command will tell you, hey, by the way, you know, that file was different, the rest was the same. So you can look into the file and see that maybe you're incrementing a version in there, and maybe you shouldn't do it in that way. Maybe you should increment the version in the output instead of in the source itself. Things like that. So that's one of the things we have been working on in the last couple of weeks, and it's already out. So if you pass us like a special flag called verbose login, it will give you all this information. So basically, we're trying to let people not just use cloud, but sort of maximize the number of cache hits, right? So there is very little computation to have to redo.
Yep. All right. Well, that's a wrap. Thank you so much, everyone, for listening and sticking around and asking so many great, interesting questions. And thank you, Bravery, for putting us on. Feel free to reach out to either of us on Twitter. Victor doesn't respond on Twitter, but I do.
I don't.
B.
Yeah,
Cross,
and
email
follow
me.
his pig page too.
Yeah, go to my pig Instagram, Jeff B. Pigs. And you can also email me, jeff@narwhal.io, especially if you're wanting to onboard on the NX cloud or try it out or have questions. Feel free to email me or Victor, and we'll answer questions and help you get started.